today's video, we're going to be going over 2D vector addition problems using components. Let's take a look at example 1. In 4.4 seconds, a bird flies 22 meters east 33 degrees north, then 11 meters east 28 degrees south. Find the total distance traveled, the average speed, the total displacement, and the average velocity. So we can see in this question that we're given two components to find. And question A and B are actually very simple because both distance and speed are scalar quantities. So all we need to do for A is just add up 22 and 11. So distance is 22 meters plus 11 meters, which is just 33 meters. And then we don't need a direction because, again, this is a scalar quantity. Now for average speed, remember that average speed is just distance over time. So now what we can do, we can just plug 33 meters over the 4.4 seconds that's given to us here. And then if you do this math, you can plug it into your calculator and you should get 7.5 meters per second. So that's A and B. Now moving on to C, this is where we're actually going to use vector components. So what I like to do is I'm going to label this as component 1 and component 2. And we're going to create a mini Cartesian plane almost and draw out our vectors. So I'm going to use this ruler and then draw a line to act as our vector. So this is going to be 22 meters. And whenever you see these directions here, east 33 degrees north means you're going to start from the east. And then what you're going to do is then you're going to move 33 degrees towards the north, starting from east and then move towards the north. So that's our first vector. Our second vector is going to be the same. So draw the dotted line. And then this one is going to be east 28 degrees south. I'll set my ruler here. Oops. And this is 11 meters. And we're starting from the east, moving 28 degrees south. So this is this angle right here, 28 degrees. And then as always, we should set up our coordinate plane, north, east, south, west. Okay, so now what we're going to do is, this is going to require some basic trigonometry, but it's not too bad. It's just 10th grade trig. So for one, we're going to find the x component and y component. So using basic trigonometry, our x component is going to be here. So it's 22 meters cosine 33 degrees. And then if you use your calculator, you should get 18.45 meters east. And for the y component, it's going to be 22 meters sine 33 degrees. Because we're looking for here, and it's opposite over hypotenuse, so that tells us we have to use sine. Plug it into your calculator, and you should get 11.98 meters north. An important trick to remember if you don't like using trigonometry is if your angle is relative to the x-axis, so like something like this angle, this would be relative to the y-axis, but if it's like this, like both of our angles here, you can just remember that the x component is always going to be cosine and y component is always going to be sine. Okay, so for our second component, it's going to be the same thing. So x2 equals 11 meters cosine 28 degrees. And this should give you 9.71 meters east. And then the y component is just 11 meters sine 28 degrees. And this should give you 5.16 meters south. So once we've established the x and y components for each individual vector, we're going to add them up and get the resultant displacement for x and y. So I'm going to do that down here. I'm going to do this as delta x. You can also use like x subscript r for resultant. Either is good. I'm just going to use delta x for this example. So when we look at these two vectors, we're taking a look at x first. So you'll notice that both of these have an east direction. So that tells us that we can just simply add them together. So like 18.45 plus 9.71 equals 28.16 meters east. Now for y, you'll notice that we have opposing directions, one north and one south. So what we need to do is actually subtract these from each other. So this step doesn't really matter which way you do it, but the simplest way is to look at which one is bigger. So I see that 11.98 is obviously bigger than 5.16. So to keep things easier, you want to switch. So basically, you want to make the directions the same. And it's always easier to switch the smaller value than the larger one, because that's going to give you a positive result when you subtract the two. So what I mean by that is we're going to keep the greater one the same. So we're going to keep this one as north. And now we're going to subtract this. So now you can see that both of our directions are the same now. So what we did is you can also, if you want to, in this step, just put negative in front. Since north and south are opposites, you just want to flip the sign in front. So you can also do it like this. So now once you subtract these, we'll get 6.82 meters north. And there we go. So you have the x and y components. And now what we need to do is they're asking for total displacement. So if we draw this out, what our resultant components look like, this is going east, 28.16 meters, and then north, 6.82 meters. So you'll notice that this is actually a right angle triangle, and to find the resultant displacement, you're just going to use Pythagorean theorem. So it's going to be delta displacement, r for resultant, and then just do Pythagorean theorem. This squared, 6.82 squared, and you should get 28.97 meters. And then we also need to take into account the direction because they're asking for displacement, which is a vector quantity. So what you can do is theta is going to equal tan, the inverse, of 6.82 over 28.16. Basically, how you remember this, your your primary trig ratio is going to be tangent always, and then how to make things easier, You usually put the smaller value on top and the larger one on the bottom. And once you do this, you should get 14 degrees. Now, how do we know if it's north of east or east of north? Well, the one that's on the bottom is going to come first. So 28 degrees was our east direction. So that tells me that it's gonna have to be east 14 degrees north. So just going over a few things again. The reason why we put the smaller value on top is because that's gonna give us the smaller degree or the smaller angle. And you can do it either way. However, most people, if teachers are picky about which angle you use, they would usually prefer that you do the smaller angle. So that's why it's a good habit to just put the smaller one on top. And then the second thing, remember that your direction that comes first should be on the bottom of the fraction. So those are quick tips to remember how to do these angles. And now, to answer the question of total displacement, we're just going to put the two values together. So the total displacement is 28.97 meters east 14 degrees north. Let me see how many sig figs we need. Should be 2, so I'm just going to round this to 29 meters east 14 degrees north. And that's the answer. Then for average velocity, this stuff is easy. We did all the hard work in part C. So what we're going to do is, we know that average velocity is displacement over time. So we're going to use this value over here for displacement and then do it 29 over 4.4. So 29 meters east 14 degrees north over 4.4 seconds is going to be 6.6 meters per second. And then once again, we need the direction because it's a vector quantity. And that's our answer. So there's question 1, a fairly simple problem. And now let's move on to example 2. Now example 2 looks a bit more complicated. And it is because we have 4 components instead of 2 this time. So it's going to be a bit more work, but the process is still the same. They're only asking one thing, which is resultant displacement this time. So we're going to go ahead and begin with the components. So I'm going to label this component 1, 2, 3, and 4. And then as usual, you need to do your plane, north, east, southwest. Okay, so starting with the first one, we're going 600 meters east 47 degrees north. So setting up our plane like this, I'm going to use the ruler and set this to 47 degrees. That looks good. So let's draw. And this is going to be 600 meters. And then once again, our angle, we start from the east and then move north. So that's going to be, it's going to look like that. Then for our second one, this is going 500 meters north, 38 degrees west. So just as before. This time our angle is going to be facing this way. And there should be, I'm just going to do it like this. The angle actually is not accurate on my diagram, but that part doesn't really matter. This is 500 meters, and this time it's a bit different. It's north 38 degrees west. So we're actually going to start from north and then go this way. So that's our angle, actually. And then 300 meters west, 20 degrees south, which will look like this. So starting from the west and going south should be 20 degrees. And 300 meters. And then lastly, part 4, 400 meters south, 13 degrees east. So that's gonna look like this. This time, again, it's gonna be starting from south and going east. Something like that. And again, this angle is not correct. Not drawn to scale, but it doesn't really matter. Okay, so we have all of our components drawn out. And now let's start with the x and y components for each. So x for component 1, this is going to be 600 meters cosine 47 degrees because adjacent over hypotenuse is cosine. This should be 409.2 meters east. Make sure to always put the direction. And then for y, it's going to be 600 meters sine 47 degrees because opposite over hypotenuse is sine. And it's going to be 438.8 north. Now for 2, you actually have 2 options here. If you'd like to memorize the shortcut of the x component is always cosine, y component is always sine, you can do 90 degrees minus 38 degrees, and then find this angle over here, and then do it as usual. Or if you don't want to do that, because this is relative to the y-axis, you can actually flip cosine and sine. So I'll do that here. And then for component 4, I'll do it the other way where you do the subtraction. So it's going to be 500 meters sine 38 degrees. And then we get 307.83 meters west. And then for y, this is also going to be flipped. So 500 meters cosine 38 degrees, which is 394 meters north. For 3, this is going to be the same thing. 300 cos 20, which is 262.39 meters west. And for y, it's 300 sine 20, which is 145.44 meters south. And then for 4, again, we have the 13 degrees, which is relative to the y-axis. So if you want to do it the alternative way, you can just do 90 degrees minus 13, which is 77 degrees. And now you know that this angle here is 77. And then now you can just do like the same old cosine is x and sine is y. So 400 meters cos 77 degrees, which is 89.98 meters in the east. And then 400 meters sine 77, which is 389.75 meters south. Okay, so all 4 components are done. And now the same thing, we're going to find the resultant displacement for x and resultant displacement for y. So over here, it's going to be delta x resultant. Now, we can do the same thing before where we look at which one is smaller and which one is larger, and that's how we decide which one to flip. However, we have so many components here. So we're just going to go ahead and do it either way, and then we'll deal with it at the end of our calculation. So let's just say we want to make all of it east. That means this one needs to flip, and this one needs to flip. So when we add them together, it's going to be 409.2 meters. I'll put east here just to make it clear. Now we need to put a minus in front. Also, it might be easier if I do it like this, so you can really see the thing works. Because you should add all of them together, but I know the minus signs might be a bit tricky. So I'll just put the brackets around, and then this should be minus 262. And then our final one is east, so we're gonna do just plus 89.98 meters east. Okay, and finally we can just add all of these up, and you should get negative 71.04 meters east. Now, because this is negative and we want our displacement to be positive, we're just going to flip the sign around, make it positive, and then flip it into the west direction. And then for delta YR, we can just do the same thing. So I'm looking here. Let's just keep everything north. You can just pick randomly. So that means this needs to flip, and then this needs to flip. So we'll do 438.8 north. I'm not going to put meters because it's just a lot to write. Plus 394 north plus negative 145. And then plus negative 389.75 meters north. And now adding all of them up, it should be 297.61 meters north. And this is positive, so we don't need to flip anything around. And then once again, our final step is to do Pythagorean theorem. So delta displacement, resultant displacement, is going to be 71.04 squared plus 297.61 squared. This is going to give you 305.97 meters. And then for our angle, theta is going to be tan inverse. And then I'm going to put the smaller one on top. So that's 71.04 west over 297.61 north. And this is going to give you 13.4. And then remember that the one that is on the bottom is going to be the first direction. So that means it's going to be north 13.4 degrees west. So hopefully that makes sense. And then finally, we can just say resultant displacement is, how many sig figs do we need? 3. So I'll do 306 meters north, 13.4 degrees west. And that's the entire question done. So don't mind this part. This is example 1. So this is all of example 2. So that's it for the video. We only have 2 examples. So if you don't understand, please maybe leave a comment or rewatch the video, and thanks for watching.